This is a demonstration of the recently completed program counter card, and I'll start with an overview of the card itself. The program counter is effectively a 16-bit register, and so it's very similar to the 8-bit registers that already exist inside the computer. In fact, the program counter really is just two 8-bit registers tied together and wired out differently. So in many ways this card is fairly unremarkable, and you'll have seen most of it before. But let's crack on anyway. So if we flip the card over, we can see the solder side, and again there's nothing too remarkable to talk about here. Actually, that said, I am getting a little bored now of having to keep putting all those ground wires down. It takes quite a lot of effort having to cut all the individual wires, trim them, solder them down. So I think what I'm going to do for future cards is just put down rails, a bit like what you see at the bottom of the card there with the LEDs. So basically just be wire connecting all the grounds together, and then the only thing that will use proper insulated wire will be the power lines. Anyhow, flipping back and going down to the front of the card, and that's where we find the program counter LEDs. As I said earlier, this is two 8-bit registers tied together, so effectively we have 16 bits for the register and then the select and the load LED. And if we head a little further up the card, and this is where we can find the 16-bit register relays, each one holding 1 bit of the 16-bit value. Going further up the card again, and this is where we find the gating relays. These will allow the value to come off of the address bus and into the register, and from the register back onto the address bus. Finally, at the top of the card, we have the usual card connectors. These are type X, so consist of the control X bus, then the address bus, then the data instruction bus, and finally the power connector. And that's pretty much it for this card. Now this certainly isn't the last register, there's lots more of these things to go. In fact, actually later on the computer it's pretty much registers all the way. Not only will there be the M, J and XY registers coming up, but even the incrementer has a register behind it as well. So there'll be lots of repetition there, and by the end of it I'll be thoroughly bored of building registers. Oh well, nobody forced me to build a computer out of relays. Anyway, let's get on and give the program counter a quick test. Without wanting to start a catchphrase, I'll start by switching on the power supply. And absolutely nothing happens. And that's fine because the register starts in its default state of no bits set. I'm now going to set the dip switches on my breadboard to set bits 0, 4, 8 and C on. And activating the load line loads the corresponding bits in the register. I can now flip the switches so that each bit it moves up one place, and then press the register load line again to load the value into the register. If I do this another 2 times, that'll cover every bit of the register. I'll now set an alternating on-off pattern and load that into the register. With that pattern now loaded, I can take the connectors for the address bus and move them off the dip switches and over to the bar display. In this case, I've moved the lower 8 bits over, which means now if I select the contents of the register, you see the lower 8 bits of the register as expected. If I now swap the cables back over again and bring over the upper 8 bits of the register, we can do the same. We're now expecting to see the upper 8 bits. And there it is. Finally, I'll put everything back to where it came from and switch all bits on and load the register. If I cut the power to the dip switches and let it register, it should knock all the bits out. In terms of power, it's quite a hungry card, this one. And as you can see, it's consuming 0.3 of an amp with all bits set. Right then, well, that looks to be working as I expected. So how about now we put the card into the computer? And saying put the card into the computer is probably oversimplifying it a bit, because actually quite a lot's happened here. First of all, I've had to build an X backplane to put the card into. The X backplane's here, and here's a program counter along with the instruction register that uses the same backplane. And adding a new backplane means adding yet more cables, and particularly the address bus, which I've had to bring up to the display B and add an address bus display shown here. Other than that, if you've been following my blog, the computer should be pretty much as you'd expect. Okay, let's power her up. Okay, if I set a pattern on the input switches, I can gate it onto the data bus. While doing so, I can also load A, B, C and D registers. As well as a data bus, I can also gate to the address bus. Let's set a different pattern on the switches. If I gate that to the address bus, I can now load the program counter. I can also select the program counter, just like I can select register D. But as on different buses, I can select both at the same time. Being able to have one value on the data bus while another value on the address bus is what will make the memory card possible, and that's the card that's coming next. But for now, that's it. As always, you can find more information on my Relay computer at relaycomputer.blogspot.co.uk.